Hello, students. Uh, Today we are discussing one more important chapter called pointers. So, I already have told during the data structure explanation, there is the necessity of learning the dynamic memory allocation. So, therefore, I'll take this chapter. So, after this chapter, we'll continue data structure. So, the pointers. So, what actually pointer means? So we know how variables are created, how we declare variables, and how we use those variables in our problem to find the solution of most of the problems. So variables are going to assist us. So let us learn about the pointers. So what is pointer and what are the operation we are going to do with the pointers? So what we are learning in this chapter. The first one, we try to understand the concept of pointers. That is, what is pointer? How do we declare pointers? And how do you initialize the pointers? And what are the operation we are performing with pointers that we try to understand. Then we think of usage of pointers, where and all we use the pointers. What's the advantages of having pointers? That also we going to discuss. And one more is the role of pointers in array, let's say derived data structures, arrays, strings, and structures, even classes, objects, all we learn. Functions, that is dynamic, and this is what very interesting, dynamic and static allocation of memory. So relation between the pointers and functions, and relation between the pointers and objects, classes and object. I think you know about object and instance of class. So therefore we learn what relation, how we can operate with the pointers. So this is what this chapter is going to cover. So normally when you look at this simple example, so computer memory is a sequential memory, continuous. Look at this memory location is blocked by the variable a, and that variable consisting of, you can see that 1008, which is the address of the variable b, you can make out that. Okay, so now this variable a, instead of containing the value, it consisting of the address of another variable, thereby making this variable indirectly pointing to this variable. Okay, so now this a is pointing to this variable because what it contains is the address of b. Indirectly it is pointing to b. So that's a simple logic. What we are discussing is pointer means, we'll learn again in detail. Just it is just imagination. Just imagine, how do you say something is pointing to some other variable? Means if that variable contains address, you can see the address of b. So indirectly a is referring to b, or it is pointing to b. So that is what pointers that we are going to discuss more technically inside. Okay, so let us we go with the introduction to this pointers. So this one, this just describing what's the use of variable, how do you declare variable, how we access the value of variable through the variable, how do we access the value of variable. That is what we are going to do. That is everything in programs. So we do with the variables. That is what is giving introduction. You can see there. So when writing a program, so we declare the necessary variables that you will need in order to accomplish any work. So when you're declaring variables, you're simply asking the computer to reserve set of amount of space of memory for a particular object that you are going to use. So when you declare a variable, the computer reserves an amount of space for that variable and uses that variable name to refer to that memory space. This is already we have learned. So this will allow you to store the value of that variable in that space. The computer refers to the space by using the address. This is, we are not just we use the name of variable, But in reality, what computer does means it doesn't work with the name, it works with the address. So therefore we can find out the address of particular variable. So normally it is when there is a exist memory space means, so it must have some address. That also you can see every human being is identified by some name, that is to recognize he has got maybe particular, whenever you want to find particular person means, or you are searching for a particular house, so it has got some address. So using the address we are able to reach, and you can perform any operations. In the same way, when you have a computers means, in a computers the memory, when you declare, when you allocate, I think you'll understand later on. So normally whenever variable is declared means there is a computer memory is a sequential. So that memory, in that memory we are going to store some value. So normally so far what we did means we have used the name of variable to perform any operation. You might have seen C in A, C in B, or C in S is equal to A plus B, C out. All the time we have used the name of variable. In fact, it also uses the address of variable. So using that address, we can perform the program more efficiently. That is what this chapter is about. We'll understand this one once we complete this chapter. And also we can see there are some advantages of pointers. So there is no meaning to discuss right now because you don't know anything about the pointers. Let us we complete the topic of pointers and we'll come back to these advantages. So now let us learn about the memory representation of pointers. So what actually memory representation means? Let us we learn something about. It's nothing but a variable. So like all other variables are allocated in the memory. In similar way, the pointer is also variable. That also declared in the same. You can see this is address. So address of memory locations. This is the first memory, second memory, third memory. It goes on like this. Let us before we get into the concept of pointers. Let us understand the memory organization. How memory is organized. So memory is organized as an array of bytes. You can see this is an array of bytes. 0 byte, 1 byte, 2 bytes, 3 bytes, something. It's in terms of byte. A, what is a byte means? It's a basic unit of storage. In computers, we represent everything in the form of bytes. That is 1 KB or MB or GB, you might have. So that's a unit of computer storage. So normally what is this byte is made up of means it is made up of bits, group of 8 bits makes 1 byte. So 1 KB means, so it is 1 kilo, the KB is a 1024 bytes. That is, the memory can be viewed as an array of memory location of size 1024 with the subscript starting from 0 to 1024. So that is the storage capacity. That's how we are going to store the if it is the capacity is 1024, that's 1 KB. This is a consecutive memory location, and these memory location can be used to represent any variable. Depending on the requirement, we can allocate this memory location. So that is the main concept associated with the memory. So whenever pointer comes, so this is what the address we are going to use. That's why this introduction is very important. We have to understand the computer memory is a sequential, and each memory has got its own address. That is how we identify using the addresses. Whenever memory location is allocated to the variables, and using those variable these addresses, we perform some operation on these values. That is a what pointers we are going to do. So that's what we are discussing. So let us, we know that whenever we declare variables, I think when you might have remembered, you can see here when we declare variable, data type, variable name. Like we declare variable means what will happen? There is a memory is allocated for this variable num. You can say allocation of memory, the number of location, how many memory you allocate, it depends on the data type. If it integer means it takes 2 bytes, if it is float means it takes 4 bytes. And one more is it establishes a relation between the address of the location, that's address of the memory space, and the name of the variable. That's what so far we are doing. This address and the name is established automatically by the compiler. That is why this is the method we are using. See, this is what an example. So when we declare a variable integer of type num means it's a number variable, and this has got address. This number has got address, and it is identified by name num. So this link between the address and the name is established during the memory allocation. That is what happens when memory is allocated. This is called memory allocation. Now let us see, this is an example. You can see, uh, so whenever I declare variable num and it has got address example 100, consecutive memory location, because 2 bytes it uses these two spaces, and also it, integer number I have initialized, I supplied some values. That is, right now we are using this name and we are updating. We are using this memory space by using the name we are operating. That is what we are doing regularly in present, last academic, and whenever we talk about variable accessing storing of variables is normally performed using name. And also you can see here, this is also referring to the same space. Indirectly, using this address also we can access. Using this address also you can access this value. That is what pointer. That is this chapter. We use the address and to perform any operation using normal variable. What are the things we did so far could also be performed with the address. That's the only difference is we are using with the name. Now let me use with this. How this we perform, that is what we are going to do. We are going to discuss in this chapter. So now let us come to the definition of pointer. So already I have seen the beginning diagram. So what is a pointer means? So pointer is a variable. Like other variable, it's also variable. So but instead of storing the values, it stores the address, memory address of another variable. So that is another variable. That is what we call as a pointer. What is a pointer means? Pointer is a variable which contains the memory address of another variable. That is what we call as a pointer. So that's a concept. So it's nothing but whatever we discussed like variable. This is also variable. So whatever the rules we applied for variables, pointers, for pointer also it applies. Only difference is the data what is we are going to store in the variable is only the memory address of other variables. So how do you declare? So how do you, because whenever we want to use it in our program means they has to be declared. How do you declare means, so normally how do you declare variable? First we use data type and then we use variable name. You can see here variable name, and then normally we have a data type. So this is for a normal variable declaration, but you can see here it is preceded by star. Variable name is preceded by star. So this is how we are going to declare pointer variable and normal variable. For normal variable we don't use star. For pointer variable we use a star. So remaining is exactly similar: data type star variable name. So what is this data type signifies here? This data type is the is it is used to identify the type of variable for which the pointer is pointing to. For example, I take its int means integer means this variable can hold the address of any integer variable. So if it is a float, it's float. So data type can be any data type. So it is simple or derived or user defined, any type of data type supported by C++ or any normally data type. So that is identified. So that a simple example means integer means it can store or it can point only to the integer type of variable. If it is a float means it can store only address of float variable or it can point only to the float variables. Similarly, character means it can point only to the character type of variables. That's how this data type, that's what the necessity of data type. Variable name is a name given to identify. You can use any valid identifier according to the requirements which you are going to use in your program. So next let us take an example. How do you declare? This is an example as we did data type and we use a star, and then I use the variable name iptr. So iptr is declared to be pointer of type integer. That indicates this iptr can take only the address of any other integer variables. And remember, this ptr is not the name associated with the pointer. You can use any valid identifier. It need not be the iptr or any, it's just a variable. So just they have to, for a descriptive purpose, they have used iptr, that is like integer pointer. There's a name they have chosen. We need not be, pointer means we must use pointer, is not a criteria. Just you can use any valid identifier. This is one more declaration where we have a fptr, and this is a float. Now this variable or this pointer can point to any type of float variable, or indirectly it can contain the value, that's the address of any variable of type float. Similarly for character, so character also we do the same thing. But you can see there, normal variable and pointers are distinguished with the prefix of star, otherwise it becomes a normal variable. This is how uh, pointer variables are declared. So now how do you initialize, how do you assign the values to the variable? Already I've told the pointer can store only address of other variable. So therefore already last academic we have learned the operators, unary operator, that is we have ampersand symbol, which is called as address operator. So you can see on exam program segment here, you can see we have declared a variable number, a which can contain the value 25. Then this example we have declared one more variable called iptr, which is a pointer type because we have a star. And now you can see there, so it is get the address now. So address of integer variable, we use this. So this is operator which will give you address of any variable. It's a unary operator, and it's operand. So this is operator, this is operand. It returns the address of this variable where it is created in the memory. So that is copied. Now you can say iptr is pointing to anywhere. Only these two statements will not conclude the pointer iptr is pointing to null. So when this statement occurs, then only you can conclude. Now you can say this iptr is pointing to the variable, integer type variable num anywhere. So that's how we assign, we get the address, we copy address to the pointer variables. So already we told about this address operator, and also last year also we have learned, just it gets the address of pointer variable in any normal variable, and that can be used to assign to the pointers. And now let us, this is an example they've given, same example. So let us learn about something about pointer operator or indirect operator. So what is this pointer operator or indirect operator means? So this is more very important things we have to understood. So that is we try to uh, access the value which is stored at the address. So normally this is very important. So whenever we use this star in front of the pointer like this, so it gives the address of the variable which is stored, which gives the value which is stored at that address. So this is called indirect operator or indirection operator. Indirectly we are trying to access the value which is stored at that address. So you can see here on a programming example is there. So normal example you can see here, we declare so normal program, a simple program. You can see make out. You can see we declare variable. There's I think no problem. Just normal variable, and we declare pointer variable, and also we declare one more variable value. So all these two are normal integer variable. This is a pointer which can store address of integer type of variable, and just we assign. So we variable, this is will contain the address 3000, that's a value, sorry, 3000, and the address of this var, that is which is created, is copied to ptr. Now ptr gets the value which is the address, and you can see this one. So when you prefix star in front of the pointer, this star is indirectly you are trying to access the value which is stored, that you can directly display here, or you can copy to the one more variable and we display. You can see the value of var as we know earlier, so it is a 3000, no problem. And value of ptr, this is very interesting because this ptr will give you the address of var. So what is this var? Its address will be displayed here. You can see here the address is, this is a different thing. So why it looks like means it's a hexadecimal form. So it's hexadecimal value we are getting. That is a that's a machine dependent. You may not get the same value. You may get different when you write it. The program, same program you write, you may not get the same value. You may get depending on your memory. It's a machine dependent in simple. And this value is the value that is 3000. That's why we get 3000. We never assign value 3000, but we, through the pointers, we are getting the value. That is very important. That is why it's called indirect. Whenever I prefix star before the pointer, means we are working with the value, not with the address. So that is something about, that's a very important about indirection operator or pointer operator. And sometimes they ask for 1 marks, which is the pointer operator star, which is indirect operator. You can also expect 1 marks question sometimes. So this is something about a simple example how pointer works. So now let us learn what are the operation we can perform with the pointer variables. That is a pointer arithmetic. You know what is the arithmetic operation? Addition, subtraction, multiplication. That is what we are going to do. Let us, with the pointers, what are the operation we are going to do. So one important thing is, because what is we are storing in a pointer is also numeric value. That's a very important. So hence we can perform all arithmetic operation, addition, subtraction, multiplication, division, and which are possible and which are not possible, we'll be discussing. Pointer operations, how we can perform, and which are the operation which is not able to perform with the pointers, we'll discuss. The arithmetic operation that can be used on pointers, like plus plus, we'll learn all those things. This is minus minus, plus, and dot operator. We'll discuss all those things one by one. The what are the operations that are we can perform with the pointer, means we can add integer value to a pointer. If you have some pointer which has address 60,455 something, or 65552 something, you can add with some 10. We'll understand later on. That is, whenever you have a pointer, means if you want to some other next memory, you can add some integer constant, some integer value can be added to the pointer. And also we can subtract an integer value. Can subtraction is also possible from a pointer. It's a constant value from pointer. You can subtract like 6550, you can subtract minus 10 is also possible. That is, we can add an integer value to a pointer, and you can subtract an integer value from a pointer. And other operation we can, what we can perform is, we can compare two pointers if they are pointing to, you can see, you can compare two pointers if they point to the elements of same array. So maybe you know array means we have a consecutive memory location, and we have P1 pointing to the second element of array, and P2 is pointing to the fourth element of an array. Hence you can compare these two pointers provided they both are pointing to the same array. That's very important. So there may be many pointers, and two or more pointers or two pointers, they must point into the same array, or they may contain address of the same elements of an array. Then you can compare them, whether less than, greater than, something like this. We can compare two pointers. Now one more is, we can subtract one pointer from another pointer if both point to the same array. That is, with the arrays we can perform many operations, like from one pointer you can subtract, you can from another pointer. That we learn when you program, you are able to understand. Because we have a consecutive memory location, all will be identified by same name, and each elements of array are identified by common name. So that's consecutive memory block, and both pointers you can declare anywhere, any elements you can declare, and if they are pointing to the same array, you can subtract from one another. That is also possible, provided both point to the same array. Then we can assign uh, one pointer to another pointer, provided both are of same type. That's also important. We have pointer P1 pointing to integer, and we have pointer P2 which is pointing to integer also. Then you can copy P1 equals P2. So if P1 is pointing to character and P2 is pointing to float, means those we cannot assign. We cannot copy from one pointer to another point. Assign is possible, or copying from one pointer to another pointer is possible only when both the pointer should be of same data type. Then only we can assign the address of one pointer to another pointers. And let us look at what are the operation which is not able to perform, which we are not able to perform, means which operation we cannot perform, means you can see the addition of two pointers. Simply we have two pointers P1 P2 somewhere, and we cannot add them. So addition of these two pointers is not possible. Subtraction of one pointer from another pointer is not possible when they do not point into the same array. So that is very important. Already beginning we said the operation possible, but if they are not pointing to the same array, then subtraction is not possible. Addition of two pointer not possible. Subtraction of one pointer from another pointer is not possible if they are not pointing to the same array. Multiplication of two pointers is not possible, we cannot perform, there is no use also. And then division of two pointers is not possible. Addition, subtraction, multiplication, division of pointers not possible, provided subtraction, if both are pointing to the same array, then only we can subtract one pointer from another point, otherwise you cannot use the division operation, the subtraction operation. So this is something about the operation. You can give you can see there are some examples. Suppose if p is a pointer, integer pointer, and then you can make p plus plus. So what does this p plus plus means? It is increased by address. So one that indirectly increased by two, because so it's a integer uses 2 bytes. We have seen example 100, 101. Both are belongs to those memory location belongs to integer only. Therefore, whenever we increase p plus plus, it is increased by 2 bytes. Similarly, when it's a float means it is increased by 4 bytes. So that's how we have to be careful whenever we work with the addresses of pointers. So that is something about the plus plus operator. Similarly, suppose if p is a character type, and then if this is exactly similar, it is increased by 1 byte. Same thing for float and long integer are different data types. They will be depending on data types, that will be increased by 4, by 8, by 2, or by 1, depending on base type, that is data type. Now you can see similarly you can perform the operation of minus minus. So each time pointer is decremented by 1. So it is previous memory location, it is shifted depending on its base type. That is integer means it is subtracted by 2, it moves to the previous 2 memory location. If it is float, minus 4, or if it is character means minus 1. So this is another example, other operation what you can perform means if there is a pointer, so pointers can be added with some integer constant or integer value. P plus, where p is a pointer, plus 100 or plus 1 or plus 2 or plus 5 you can perform. If p is a pointer which contains some value already, so that can be subtracted by some integer value. So if it is 6550 means you can use minus 10. So that's also possible. That goes to previous memory location. So these are the operation which we discussed, and it is just an example how we can perform the operation. So now let us learn about the relation between the pointers and arrays. So what relation exists between the pointers and arrays? You can say the array is already we discussed about. Array is a linear data structure where the elements of array are stored in consecutive memory location. You can see there. So all the elements of array are in like this: a of 0, a of 1, a of 2. So we have address 6550, 6551, 6552, 6553, and 6554. So this may be the address of variable. That's each elements of an array. And so far we never discussed about what is this a. So we declare integer. This is how we declare one dimension array: data type, array name, size. So what this a consisting of, we never discussed. So just we thought it's an array name. In reality, what this a will be consisting of? Just we took a of 0 is referring to this memory, a of 1 is referring to this memory location, a of 2. But what is a is not we discussed. That is what compiler does. That is what the pointer. That's why there is a relation between the pointers and arrays. This actually array name is behaves like a pointer. So normally this array name contains the address of the first element, that is a of 0. What is a means? This address 6550 means this a will always contains the address of the first element 6550 if it is any address. That's address of the first element. That's also known as the base address. So depending that's base address, we are going to calculate the address of any element. Already we discussed about how we calculate the address of particular element in an array. So that is how we are going to use the formula using the base address plus w into I minus lower bound. So where w represents number of words per memory, that is nothing but base data type. So depending on units, that's what a of 0 integer means 2 bytes, float means we have 4 bytes, something like this. So that is what something about the arrays. We'll take an example, you'll understand how it works. You can see there an example. We are trying to discuss the concept of pointers. Now normally what happens means whenever we use an array, we use a subscript and then we use the size of an array. You can see here, instead of using a of I we have used something different here. So this is like a pointer. What A already I have told, this A contains address of the first element. You can see input number of elements n, and then you can see a number of elements 5. I've given a value, so n becomes 5, and enter the elements. Now you can see here A plus I. What is A means? If it is the address is 6550, so it becomes 6550. And star means the value which is we are going to operate on that address 6550. So your input 1 means this 1 is stored in the array, that is A of 0 is 1. Similarly, I plus plus. So I plus plus means 6551 now. If it is, let us assume 1. So now 6551 means, so its address. What you are trying to do means we are supplying the value to. Like this, it repeats for all the elements, and then 3, and then 4, and then 5. So this is how array is created, and we quit. It's a creation of array. And here I use the pointers indirectly. That's using the address we are operated the values on that memory location. This is, you can see here, I have not used address operator, because A itself, that's array name itself, consisting of address of the first element. And this is the same thing we are trying to display. So we created an array. Array will be having these elements: A of 0, A of 1, A of 2, A of 3, A of 4. The same thing we repeat, and also you can make out. So we are using the address. Instead of using A of square bracket I use A plus I. So this is the address, and every time it is increased by unit depending on data type, and star will give you, so what is that, 65501, that will be displayed. And then set with 4, it gives this space, and 2, and then the address is increased with I value. This is how it will be displayed. So this is a typical example or how pointers and array works. So very simple. Whenever we talk about pointers means, so it is the name of array itself is like a pointer which contains address of the first element of an array. So therefore it will work like pointers. You can see exactly point like pointer. We did like a pointer using indirect operator. So far what we did arrays in the last previous programs, we use the array name and then subscript. Here we use array name as a pointer star. So this also this becomes efficient program. We learn when we learn other program, you're able to understand. This concept you have to go with. This is something about arrays and pointers. Next we learn about array of pointers. So what is this array of pointer means? Array means, array is a collection of element. There are more than one or two elements. So now we have each elements of an array. You can see this is I declared IPTR, and also I define star. So now I declared an array which can store addresses of integer variable. You can see here that's a star, maximum 5. So they are mentioned. So that's why you can see this I is integer variable, J is also integer variable, and K is also integer variable, L, and similarly M is also integer variable with some initial values. You can see here now the first element of an array is address of I. Second element of an array is the address of J. Similarly, address of K, address of L, address of M. So now using this star, so what is now just IPTR will give you the address of I, address of J, address of K, address of L. But when you prefix star, you can see there. So when you prefix star here, so that gives the value. So this gives address where I is present. But star means the value which is stored at that address. So that is the value of I. Similarly for other way, that's the example. That is, you can have an array consisting of only pointers, but you can, because array is a similar type, for that what we did means, so this array can store only integer type of variables addresses. That's why it's called integer pointer array. Similarly, you can use any type of arrays there which is going to store a different type of different variables of same type. They may not be the different data type. There may be different variables of same type. Their addresses can be stored in a array. That is what we call array of pointers. So next we learn pointers and string. I think this is very similar to arrays and pointers concept only. Only thing is, instead of you can see a character, so the data type is exclusively restricted to character only. So that is what we called as pointer That's a pointers and string. So whenever we talk about string means, what is string means? String is array of characters terminated by null character. So definition we have. So it is an array of characters. So you can see array of character. S is array of character. So therefore I also declare a pointer which is can store address of character type. You can see here I am copying S to the pointer. So what is noticed here? So you may be thinking, sir, address operator is missing, because it's an array means it doesn't require address, because the s itself contains address of the first element. Therefore now the cptr is pointing to string. So whenever we perform the operation with strings means, so just a normal operation previously what we discussed with the array same, but only difference is instead of numbers it will be characters only. That is, you can take an example. You can see here this is an array. You can see here we have h e l l o null character. So array of characters terminated by null character is called string. So you can see here, so I created an array s. So this all mistake, so it's s, think all are s only. Okay, printing mistake is there. So these are all s. So now this is our initialized string. So constant hello. So here s gives the address of h. So if it is 1025, so what this s consisting means 1025, not h. But when I use a star s, it is a is showing, so it is a s. When I say star s means that will give you the value h, so not the address of h. So that's the difference. You can see here s of 0 same, s of 0 is h, or star s is both are same. A plus plus means, sorry, s plus plus means, so s will be moved to the next memory, and that is gives the address of e. Star a plus plus means that gives the value of e. That is the basics. If you understand these things and you know how pointer works, you have understood. That's the most important is the star and without star. Star means the value we are referring, like star s, it is the value. Just s means it's address. So plus plus goes to next memory. Again star, without star. Without star means address. Star means the value. That's how it works. That's the pointers and strings. Exactly similar. I think it's not difficult. Okay, we'll go to the next. Pointers and functions. So we have a function parameter. You know what is a parameter means? Whenever we invoke functions, sometimes we send values. Already we have learned call by value, call by reference, the way of invoking or calling of functions. So that's why there is actual argument and formal arguments. So pointer is a variable. Already we discussed pointer is a variable. Hence it can be passed. You can send. You can pass as a argument or parameter to the functions. So that is, pointer can be a parameter. That is, indirectly you can pass pointers as an argument to the functions. So it works like a reference to the arguments within the functions. So that is what we are going to see. You can see here. So this x and y, you can see x is a variable. So normally we formal arguments y. So but what is the it is indicating, we prefix by star. Hence this is a pointer which can store address of integer variable. This is also pointer which can store address of integer variable. But what x and y are the argument of the function called swap. We have function swap, so its arguments are x and y. So it's a normal variable, no problem. This is the, so look at this. We are referring the value of the address which is contained in x. You can see here the address we passed here num, and it goes to the x. So indirectly here it is representing the value of number 1. In num1 is copied to temp, like that. Similarly star y means we are referring to the address of num2. So that value is copied to x. That's how we are exchanging. That is, at the end of this program, what happens means this program segment, so num1 and num2, their values or get swapped, they are interchanged. If we do not use a star means only addresses are exchanged. So that's the difference. This is using the pointers. That's a function swap uses the pointers to swap the values of two variables. That's how the function as a parameter. That's how we can understand. There's a simple programs. If you want, you can test and write this program. It works. Next, one more is, let us learn about pointers and structures. Already we learned about pointers and structures last academic. That is only structures. Pointer right now we already know. So whenever we talk about structures, means structures are defined in two steps. One is a definition of structure. So this part semicolon till here it is called as a definition of structure, and this is called as a declaration of structure. So structure is defined by two steps. First is a definition. Definition is used to identify all the members that is going to form the structure, and this is a declaration. So already we know so many things. It never allocate memory, only declaration that allocates memory. So let us take an example. Struct keyword, which is used to identify this. We are going to define structure. So data type and member 1, data type member 2, they can have many members, and it is terminated by semicolon. That is the end of structure definition. That we call as a template. So student now is a variable, that is a structure type, and you can declare variable s is of type student. What is student means? It's a structure with these members. So now let us we take the address of structure. So S is a variable. Remember, structures and arrays are not the same. They are entirely different. So therefore, the structure will not contain the address of the first member. So therefore, it is not same. So what S is a normal variable, but it can store. We have to get the address. So this is how. So therefore, now I created. I've done in. This is the first step. You can see I've declared. I defined pointer till here sp, which can store address of student type. So this is a normal variable student. So we get the address. So now I did two things: declaration of student structure like sp, and also making point that sp to s. So this is how it is done. Suppose you want to access these members. How do you access members of structure? Means using dot operator. Like through this, if you want to access, means s dot roll number, s dot fees. This is what we have learned in the last year, last academic, how the structures functions. Now what happens now, because these are the members of structure, yes, student structure, yes. So similarly, when you have pointer sp is also referring to the same memory location. So therefore what we do means same thing. Sp is address dot roll number, that gives the address. Sp dot roll number will give you the address of this variable. When I put star means we are referring to the value. That's the only difference. Remaining is same. So now 104 is copied to the roll number. So now what you can do means, so this thing can be replaced. What we have till here, this can be replaced by this arrow sign. That is a pointer name followed by this one. You can see here sp, this is the roll number. Now this part can be replaced by sb arrow. We don't get arrow symbol, so it is hyphen and greater than sign. This is exact, both are same. So in the future we use this method only. Whenever we talk about structures and classes, objects we discussing, means we use this one. This is how we access the members. Indirectly, it is a star sp dot roll number is same as sp arrow roll number. So we are accessing the values. Don't remember here, it's not the address, it's the value. This symbol always refer to the value. So that is something about structures and pointers. So next we have a memory allocation. That is, we have a dynamic memory allocation and static memory allocations. So that will continue in the next class. Okay. So I hope this different method I am trying, because I had some problem. I cannot go to the college right now. So maybe 1 or 2 days I'll change. I'll do it on the class only. But right now, try to if I have a doubts, any problems, let me know that, so that I'll explain once again. Okay, thank you.